So here's the anatomy of the for loop. It takes three sections, so three parts inside that pair of parentheses. And the first part is called the loop initialization. Okay, this part here in green, so you separate each section with a semicolon. So the first part here, it only runs at one time. So you initialize the variable. Okay, it's kind of like the counter. We initialize count equals 1 in the while loop. So it's almost as if it's outside of the loop, but it is not. It's part of the loop, but it only runs at one time. Again, its purpose is to prime your counter, right? So in this case, you're priming the I to 0. So this is the starting value, which is 0. Then the second part here in blue is the condition that needs to be checked. Okay, so the here will be like the condition, whatever that condition may be. I is less than 10, or you can put a compound condition in there, or you can call it function. That function must return a Boolean type. Okay, it's always true or false, right? And then the third section over here in orange, or kind of yellowish, is the control variable, right? You increment that value or you decrement it depending on which direction you want to go. If you're going from 0 to a large number, then you put your plus plus. If you're going down, count down from a 10 to 0, then you put minus minus here. So this is the incrementing or the decrementing part of the loop. The order, though, is you will go, when the loop starts, it's going to call the initialization part in green. This is first the order, and then it checks for the condition. Okay, if that is true, again, only if it's true, then it will execute the loop statements down here at the body. Okay, it runs everything here until the end of that body, and it reaches the curlies here, and then it goes back out here to the head here and check that orange part, the third section. So this third section here is checked last. Okay, so it's not 1, 2, and 3, and then the body. Okay, it's 1, 2, and then the body, and then 3 here at the end here. So after that I is incremented, it's going to go back to the condition only. So it won't go back to the green part anymore. Okay, so the first section only runs one time. So we've got 1 here, 2, 3 the body, and then 4 orange part. If it's, you increment that, and then it goes back to the second part again, and then the cycle starts in here. So these 3 sections here is where the loop occurs. Okay, so again, when you do your incrementation on the section here, make sure that this is one of those variables that will cause this condition to be false. Otherwise, you run into that infinite loop again. Okay, so let's look at an example in the code, and I'm going to comment all these out. So let's go to the top here. Give some more space. I'm still inside the main method, by the way. So this is the for loop. Okay, there is another loop. It's also called for, but you use that to iterate through arrays, and we'll deal with that later. But this is a typical loop that you can use for not just arrays, for anything. So the syntax is the word for, followed by the first part here, and then the condition, and then the third part over here, and then your curlies. Okay, notice that it didn't give me any error. Okay. There's no error. If I run, you see that it actually runs. There's no error. And that is the trick about for loop. Okay. And if you want to see what it does, you can put something inside here, see if it shows anything, right? This out, and put a high in here, and see what happens. As long as you have these 3 parts separated like this, even though they're empty, it's still like a legal loop. I mean, as you can see, it goes forever, right? So you have that automatic infinite loop because there's no terminating point from that condition. So as you can see, it goes forever. and just be careful with that. Some languages will not let you do this. You have to have something here, but Java tends to have, I think JavaScript might even allow this. So the first part is the initialization. Usually when you do a count, a for loop, it's always an integer only. Okay, you cannot do like characters and things like that. The counter is always integer. So that is why it's not, it may not be useful for other cases. Okay, so with the while loop, you can check anything. You can test for a Boolean, test for character strings, test for integers. But the loop you have to use, the counter will also be integer, whole numbers only. Okay, so I'll start with a counter is very common to have I. You'll see that all the time. Because it doesn't mean anything. It's just an index. Then you can use that as an index. Later on when we learn about arrays, you see that you can put that as part of the index, a value. So I'm starting from 0. This is part 1. Part 2 is the condition. So you want to loop, let's just say, a number from 1 to, I don't know, 10, right? You want to print 10 numbers from 1 to 10. So instead of writing that 10 times in a 10 lines, you put that into a loop. And then starting from 0, maybe from 0 to 10. And then we'll check that one as long as I is less than, let's say, including 10, right? Less than or equal to 10. As long as that condition is true, then run the body of the loop. Okay, execute these statements. Once it's done, in this case, I only have one, but we can add another statement here. Well, we can replace this with the numbers. So I'm going to say, just put I here. We're going to print I to the console. So we print 0, and then we'll increment that. So initially, the rule is you increment your variable over here, okay, in the third section over here. You don't have to, but usually that's the case. Okay, it's always over here. You can put this in the body too. That'll work as well. But that's kind of like, you know, it's a disservice to the for loop, kind of, right? The for loop it's built to do it this way. But you can hack it by putting the I++ down here in the body. Okay. So it will again initialize to 0. You start from 0. Is 0 less than 10? Yes. Print 0. I'm done. Go back, and then you increment the I to now 1, and then goes back to 1. Is less or equal to 10? True. And you keep going that and do it. You'll print from 0 all the way to 10 until it reaches 11. 11 is no longer true because it's larger than 10. It's false, then it exits out of the loop. So then he'll put a message here again, done. Yes?
So the incrementing of the I variable, does that happen at I less than 10, and then go ahead and increment the variable, then run through the loop, and then it comes back up to like when does it execute, I guess? Is it all that
Yeah.
same thread?
Well, yes. Well, it calls this first. The first thing you run, it checks for that.
Yeah, that's the first one.
And then it does the comparison.
Yeah.
If that is true, then it goes to the body part.
Oh, it goes right
Yeah, it goes to the body.
So
And
if
then
I'm
it
using
does,
I,
this is
for
last.
some reason, probably using the value of I inside the body.
Yeah, so this will check last. So if you put that in here, then that is, it will still work. Okay, so yeah. But this is the last part here. Okay, so if you run this again, you see that it's printed from 0 to 10, and then once it reaches 11, it's done. So notice that this variable I is it's a block, has a block scope only inside the for loop. Okay, it does not exist outside of the for loop. So if you were to use I again outside here, it's going to be incorrect. So if you were to use like print I, you see that I is not accessible, right? We learn about variable scopes and block scopes. Okay, so because I declare I inside the for loop. So it's part of this for loop only. If you want to use I, if I is important, maybe because you want to say, you want to print the last number after I is printed, you could initialize this outside of the for loop, put outside, and then you can set that to 0, or you can say I is 0 in here. Okay, either way. And so now I is visible outside. So when I print I, you'll see that it will print I, which is 11 at the end of that number, okay, of that loop. If that's something that is important, then you put outside. So also when I put I here, I did not initialize it to 0. I could say I equals 0 here, and I equals 0 again. Again, this is redundant, right? I could just completely take that out and leave it blank because I already initialized I, and I is still being tested here. Again, this probably runs once, so it doesn't matter in this case. I already initialized I to 0. Okay, so you can do this, but again, it's a little bit off because it doesn't have those 3 parts in the loop. Okay, so usually you put it there. Again, if that's important, you initialize it inside here. Again, you don't have to start at 0. You can start at any number. You can start at 4 if that's important.
Okay. Yeah, well, I don't like starting at 0.
Yeah. So it's only important when you use arrays. That's important. But otherwise, yeah, you can start any number you want. You can start at a random number. Okay, so this is a typical for loop. You can also use other variables in here. Maybe you want to also use j, so you could say int j is also at 0. Oh, actually, I can put int here. I have to initialize outside. So int j, and then j is 0, and maybe I want to use j for something inside the code. Okay, so you can do that as well. Actually, if I were to, yeah, so if you do this, I can't put int here unless if I completely move these out, and then I can do int inside, so both will be like int j. So maybe j could be something like j equals j, plus 2, I don't know, something like that, and then we use j for something. Okay, so you can have multiple variables in here. You're not limited to just 2. You can have n number of variables, x, y, z, whatever it is you need to initialize before you use in the code. Yeah, right. So because I put a comma, I mean whatever comes after it also be integer type. Yeah. And the condition is the same thing. You're not limited to just 1. You could have a compound condition. Okay, so you can say when I is less than or equal to 10, or you can say when j is greater than 5. Okay, you can do that as well. Now both conditions will be tested because it's still part of that condition block. So I'll just do that so you can see easier. You can do that. So one of those is true, then it will continue with the loop. In this case, it'll be true because this is true, and j is false. But it doesn't matter because this is already true. I'm using the or. So back-to-back compound condition again. Very tricky. Also over here, you can do not just one. You can do multiple. You can even do some things like if you have a variable outside here. I put that in my notes as well. Maybe you can say sum equals j plus I, right? You can redo that, do this operation here inside the block.
Is that common?
Yes, the comma.
No, I mean, is it common?
Comment? No.
No.
I just say you can.
Just showing you.
Yeah, because sometimes maybe I don't need this. I just want to do that. I just want to add a sum of j and I. So some programmers like to do this because they want to make it look complicated, right? Look sophisticated. Looks, oh, they're so cool. So this, I can do this, and if I take that out, right? So I'm going to add j to I, and then at the end I get the sum. I do sum here, and then sum is not allowed because again you have to, the rule always initialize, and then when you run this you get a sum of 22 because you are doubling the j, the I and the j, so you just add it twice pretty much, so you get that number. Okay, for that purpose, but again this is not common. Okay, so just so you can, I hope I'm not confusing you further, but just say you can do that. But typically, one variable, one condition, and then you increment that part at the end. Okay, so let's do something a little bit more practical here. Let's just say I'm going to go back to what I had before, and let's just find and print, we'll put like from 1 to 100. Okay, 0 to 100. Oh, 1 is fine. We're going to print all the even numbers, right? If it's odd, we'll skip. If it's even, we'll print it out. So you use a for loop to do that again, because for loop tells us the lower bound and the upper bound. We know that, so it's much more efficient this way. You can also accomplish using the while loop. So we'll say, so how do you test for even numbers? How do we know if it's even? Yeah, I know. How, right, that's how you do it. That's how you say it. How do you do it? That is the correct syntax, right? I mean, that is right. You divide it by 2, and you look for a remainder of 0, right? So in the code, you do it just like that. So that is perfect for pseudocode. Okay. So we'll say if the I, which has test for 1, to get the remainder, you say we use the modulus operator, which is this %. Okay, that will return the remainder only. And if divided by 2 equals 0, right? So that means it's positive. I mean, it's yeah, it's even number. Okay, it will print out I. Otherwise, we'll skip it. Okay, so that will print all the even numbers from 1 to 100. So here we go, and plus 0 at the end because we didn't do sum, but we'll just add that in here anyway. So it's from 2 all the way to 100 inclusive. Okay? Yeah. What about multiples of 5? How would you do it? Or all the numbers, multiples of 5, or multiples of 3, right? Yeah. So you just basically put the number here, whatever that number is. Okay. If it's divisible by 5, then you're going to get a 0 remainder. Okay. And that is divisible by 5, so that is a multiple of 5, and you get all the 5s and they're from 5 to 1 to 100. Okay. So as you can see, once you have this program, it gets a little bit interesting and it gets complicated, and you want to sometimes explore, like find all the prime numbers between 1 and 1,000, right? You see that a lot in if you go for a job and they ask you those kind of tests. They'll ask you those, so you have to code it. And then find all the numbers between 1 and 100. Say find 2 numbers between 1 and 100. If you multiply them, you get a certain value. So again, those are things that you have to deal with. Again, this is some algorithm you have to solve. Okay, so divisible by 5 is the same thing as divisible by 2, which is even number. And if it's odd, then we'll just say not equal 0, right? That's odd number. Or you can say it's greater than 0. Or you can just say lots of ways. You put that in here, and you wrap that into, and then you put that pound exclamation mark, right? Again, it's not even. Okay, so Now I'm printing all the odd numbers up to 1 and 100. Okay. So this loop here is the for loop. How will we do this in the while loop? How would you build this in a while loop? So the while loop, remember, we cannot initialize a set variable inside the condition in the parentheses here, right? So it's a while. I can't say j equals 0. I cannot do that. Okay. So while something, and then we'll run here, and the test will still be the same. So we'll just say copy this, put it in here, and we'll put j this time because you already used I. So for that j, we have to say the condition, right? The condition part is this part right here. Okay. So when j is less than or equal to 100, and then you have to initialize j outside of the loop. Okay. And then don't forget to increment j. Okay. So you can see. So if you compare these two loops, I guess you can see that's why you have to like kind of choose which one you want to use. Oh, down there, just say down. Up here? Up here?
Yes, it's there if we change print line so it doesn't put a period or a line.
Oh, yeah, well, sure.
But I don't know.
Yeah, we could do that. Maybe like print and then put a space. And then we'll shrink this down to like just 50. It's too large maybe. And after that, we have to call the carriage return. So we'll print that return. Otherwise, it won't look nice. So put just print line, blank carriage return. Okay, so here we have two loops. Well, the second one I didn't put that print, but the second one down here we'll put j. Space, and then this is I plus I. Okay, so we print all the I's and you print all the J's, but then again, that's not nice. Yeah, just J. Okay, so all the I's and J's, and you can see that they're the same. Okay, 150. So in this case, it's completely up to you. Whichever you want to use, it's fine. Only thing is that if you do it this way, you are wasting a variable. This you don't. Okay, because once you run the loop here, I gets used, but once it's done, I is being collected by the garbage collector. It removes from memory. Here, J still remains afterwards, because you cannot initialize J inside here. That is one disadvantage if that is concerned. Not only that, you might forget to increment this. We saw that earlier. That could be a hard to catch. But here, it's really fast. Set it, check it, increment it, so you will never miss it. Okay. Okay, any questions on the for loop? So the for loop is very, very handy when you know the boundaries. Okay, and of course you can always stop the loop prematurely too. Same thing. You can say down here, like we did earlier, I can say if when I is equal to a certain number, let me 23. Okay, if that's the case, then break out of the loop. Okay, that will cause a premature termination of that loop. Maybe because you only want that. Maybe this number could be a secret number that we look for in the code. If it matches the number, especially when you look for a number in a list of data, if it matches, if it's found, then we can break that loop and done. Okay, so in this case, it's just going to print up to 23 and stops, and then after that, it will go to the next loop. Okay, so we pause. So we cause an explicit termination of the loop here. Okay, let's see what else. Okay, just be careful with, I mentioned earlier last time as well, when you do any condition test, or even the for loops or a while loop, that you want to, if you put a semicolon here, right, I showed you last time with the if and else block, okay, that is completely legal. We'll accept that we know that I doesn't, in this case, we caught it because I is here. It's not initialized. But if I were to be outside of it, if I were outside here, okay, and if I had it this way, okay, no, this part is, it tells you, which is great, right? This IDE tells you that you cannot have break there. You're breaking from out of what? You say, oh, I'm doing for loop, but this is not even, this is no longer inside a loop because you terminated a loop here. Okay, so if you run this in a different IDE, it will just break it. If I just comment that out, for example, you see that there's no error in here anymore, and if you run this, then it's going to run it because you have a terminating variable here up to 50. When x is 51, then it's done, and then you're not going to get the result you wanted because this part is no longer part of the for loop. Okay, this is a block of code which can exist on its own. Okay, so same thing with the while loop. Just be careful with those. I know sometimes we type really fast and then you just put that there and you forget. Same thing. Okay. Those are just two very common pitfalls you want to watch out. Now, the next one I want to do is I can put all of these, okay, inside here. So let's just say we take that out, and I have a loop inside a loop. Okay, so you have a nested loop. Again, it doesn't have to be the same type. It could be a different loop. It doesn't matter. As long as it's contained completely within the loop, the for loop. So this is the outer loop, and this is the inner loop. So we say the outer for loop, the inner while loop. If you have another one, say inner, and then keep going down that chain. But usually, it's very common to have two loops. Sometimes you might have 3 or 4, depending on how deep you want to go down again. But usually 2 is very common. So you always hear the term inner, outer loop. So here, if I'm doing this way, and if you were asked to do some type of, mathematical calculation of like how many times does this code execute, okay? So because you have a nested loop, the first is you run like 50 times well, actually 51 because including, well, yeah, 50 because we wanted 50. So 50 times, and then the inner loop you have also 50 times. In this case, 51 because we're doing including 0. So if I put like j goes 1, okay. So we have 50 times, and then another 50 times inside. So for each I run 50 times. Okay, so you get a 50 times 50 iteration. Okay, so like 2,500 cycles through this whole statements here. If you want to make sure that's true, we can do the sum. We can say down here, yeah, so when j with j, we say sum is equal to sum plus 1, or sum plus plus. And we'll print the sum and see what happens. Okay. Print. Did it print somewhere? Oh, because I didn't set the, yeah, I didn't reset the value back to j. That can't be right. So run 1 time, and then 50 times. Yeah, I increase sum at 0, so it'll be plus 50 times. When j reaches 50, it exits, goes to the next one. It should run 50 times again. Yeah, something's not right, but it should be more than that. It shouldn't be just 50. Yeah, it's more than 50. It has to be 2,000 something times. Because you multiply this times that many times. Okay, so just so you know that when you do a nested loop like that, you multiply the number of iterations from here to here. If you're resetting this every time. Oh, there it is. There it is. Good catch. Man. Yeah. Should throw you a quarter for that. No, that's great because again we caught the error. Now is it doing something? I probably did something wrong too. Yeah, it's not. Well, let's see. If that is true, then it's going to run the j. Less than that, it runs to that loop. And then j plus plus, you sum the plus the sum. Yeah, that should be correct. Why isn't that printing it? But yeah, there it is. So I had some issue here. So you can see that it prints. It runs 2,500 times because it's 50 times 50. So if you have a third loop inside, so it's 3 to the power of how many nested loops you have inside. Okay. And sometimes you have to deal with those issues when you talk about the big O notation in terms of performance. So the exam for like this kind of job, they ask you, what is the performance here? How can you improve it? And things like that. So, all right. Anything else that we should talk about? If not, I think that's all I have for today. The nested loop. So you can see that when you combine this with all your if and else and your switch cases blocks, you can have all these combination of structures combined together to make some really powerful programs. Okay, so you can even write a game just using these control structures. Very, very useful. One thing that you may wonder, which you may have never, maybe haven't thought about, is this main method. Have you ever wondered that this is a function that we call like functions down here, these functions at the bottom here before? What would happen if you call the main function itself, right? Okay, it doesn't mean you can't. You can call the main function. So that means that you can call the main function here. As long as you met the requirements, it's a string, array of strings, so you can put string. Or in fact, actually you can pass it to itself if you want. But a string array, we'll talk about this later, is S, and then A, B. So this is the array. You put S in there, and then when the function runs, it calls the main, and then it does these, and then it calls the main function itself. I pass in the S because it's a array of strings. You look at this structure, it matches this structure, right? Has matched the signature, and it calls itself. It goes through here again. It calls again, so you ended up in a loop. Okay, so you have, it's like the for loop or the while loop, same thing. The function call itself. This is what's called a what? Have you heard this before? Okay, a function call itself is called a recursion. Okay, because it recurs itself again. So recursive call or a recursion. If you have the word recursion, that's what it means. A function that calls itself is a recursion. In this case, because I don't have a way to terminate this loop. Imagine that if I call main method, it goes in here, it runs just this couple lines of code. So I'm stuck here forever, okay? Just those part. And you see if I run it, it's gonna run forever, and you have an infinite loop, and it crashes the system because too many times, right? So you can check it when you run it. You can check the arguments. If it's not empty, if the argument is not empty, and if it contains A or B, then you pause. You exit the loop. Otherwise, you call it. And this is very, very famous. A way, as very popular as you get better in programming, that you make a lot of recursive calls, especially when you do something like when you calculate the Fibonacci number, right? Because it's the same, it's like a tree, it's the same thing, every little piece in there is the same call. So instead of, you can do with the for loop, that's completely fine, or you'll find that a Fibonacci number, you can use it with the recursion call, because you do the calculations here. If it's not, when n is not 1, or if it's not 2, then you call the function again until you get to one of those base cases that would terminate the loop. So recursion calls is very, very popular. Again, if you want to go into a little bit advanced coding, like we work with binary search trees and sortings and finding a set of numbers and a list of numbers, and you run into recursions. Okay, so okay, so don't try this at home. I'll just let you know that you can call the main function itself. If you do call it, just make sure you know a way to stop it. Okay. Other than that, so it's the main. Like we did it down here, right? We did the function call. I'm calling from the like here, right? You go to the car, go home, and then go home back to car. It's the same thing. I'm calling two functions, but I couldn't call itself. So just say, go to car all the time until you satisfy something in the code and you cause the code to terminate. So that's a recursion.